Here's my complete solution for the discriminator class. At a quick glance, you can see that this is just a series of 5 convolutional layers and some batch norm. The first layer will take in an RGB image as input, and so the input depth is 3. And then this creates a convolutional layer with a depth of convdim, or a default value of 64. I'm also using a kernel size of 4, and since this is the first layer, I'm setting batch norm to false. Alright, then I have a few layers that do have batch normalization applied. And these are just normal strided convolutional layers that increase the depth of the outputs from 64 to 128, and then from 128 to 256, and finally to a depth of 512, or convdim times 8. As an image passes through these layers, I also know that these should downsample the x and y dimensions of any image by a factor of 2. So I've actually written the dimensions of each output here. And by the end of layer 4, I'll have gone from a 128 by 128 by 3 input image, downsampled to get an 8 by 8 by 512 output. Then we reach the last convolutional layer, conv5, which is just going to be our classification layer. This is a normal, not strided convolutional layer that will take in our convdim times 8 number of outputs from the previous layer and produce one value as output. This will be the discriminator logic that indicates whether an image is real or fake. To indicate that this is not a strided convolutional layer, I'll have a stride equal to 1, a padding equal to 1, and batch norm set to false. Instead of using our helper conv function here, you could have also just used nn.conv2d to create this layer. And as always, this is just one possible solution. So that completes the init function. And then in the forward function, I'm just passing an input x through the convolutional layers in sequence. I'm passing x through our first convolutional layer, applying a ReLU activation, and getting some output. Then I'm passing this output to our next layer and next, applying ReLU activations to all but the last convolutional layer. And that's it, a deep convolutional discriminator class. This completes one of our types of adversarial networks. Next, let's talk about the generator.